we're projecting that over the next 3 decades that global mean temperature we expect that it will increase by about another degrees Celsius or 1.8 degrees Fahrenheit. And so a lot of the research in the community and the research that I do is focused on trying to understand what kind of climate changes we might experience on very local levels from this global warming.
So we've assembled some individuals from all over the world. We have Pakistan, we have Finland, we have Canada. So first off, let's start with you all in our hangout, introducing ourselves before we get to some of these issues. Hassan Shabir in Pakistan, let's start with you.
Hello, I am Hassan Shabir, and I am from Pakistan. And I have a question which I'll ask later. Right now.
Sounds good. Jana?
Hi, my name is Jana Nyström, and I'm from Finland, central Finland.
Kempton?
Hi, I'm Kempton Lem. I'm from Calgary, Canada.
Michael?
Hi, I'm Michael. I live in Brisbane in Australia.
Mike Downs?
Hi everyone, I'm Mike Downs from England.
Theo?
Hi, I'm Pio from Venice, Italy.
Robert.
And Robert Redl from Vienna, Austria.
Great. We appreciate all of you being with us here today from all over the world. Want to talk a little bit about some of the questions that you all have and to talk specifically about how the climate has changed in your parts of the world. So Hassan Shabir in Pakistan, why don't we start with you? What question do you have for Noah?
Well, I mean, about a decade ago, or I'd say half a decade ago, the monsoons used to happen like clockwork. Like I mean, everybody used to know that July and August is going to be the months of monsoon. But now everything just has been like disrupted really abruptly, and it's like I mean we've had about 10 months of no rain, and it's like there is no pattern that actually exists anymore. So my question is, like, is this whole climate change have made things delayed a bit, or have they contributed towards just disrupting everything?
Well, that's a great question, and my first PhD student is from Pakistan actually, and now works at the Oak Ridge National Lab. And one of his dissertation chapters focused on this question exactly for the South Asian monsoon. And what he found in his dissertation work was that global warming should delay the onset of the South Asian monsoon by affecting the atmospheric circulation that brings those monsoon rains. So what you're describing is certainly consistent with our findings for large increases in greenhouse gas concentrations. I think one of the main challenges in really answering the question that you're asking about what's happened over the last few decades is that the climate system is very noisy. It's a chaotic system with lots of complexities. And so it can be difficult to distinguish robust changes over a short time period from the noise in the climate system. But what you're describing is certainly consistent with what we expect for global warming.
All right.
Oh, okay.
Let's go to Jana in Finland. How about in your neck of the woods? Have you seen a dramatic change in climate over the decades in your area?
Well, I certainly have. Well, depends what you call dramatic, but for instance, nowadays it seems that our winters start very late compared to when I was a kid. We used to have snow when December came, and now we're lucky if we get white Christmas in parts of the country. And now it has been forecast that the Finnish climate, what we have now on the south coast, that in 100 years' time, they never go below 0 Celsius degrees. And in Lapland will have the climate that is now in southern Finland, which is, you know, snow and everything still. But it's very worrying, and I don't know if it has anything to do with El Niño and all these things, that we seem to get a lot of moist air from the Caribbean, which brings a lot of rain. For instance, in Scandinavia, the rains have increased like 15–20% in the last century. And it doesn't always come down as snow, so the weather definitely is warmer, I mean, on average.
Yeah, so there's also been a lot of research on this question. This is also what we would expect with global warming, and where the part of the world you're talking about in Northern Europe is very sensitive to what's called the NAO, or the North Atlantic Oscillation, and this is a mode of variability from year to year that helps to determine which part of Europe is cold and wet and which part is warm and dry. So that variability certainly interacts with the global warming that we're experiencing, and what you're describing about a shift from snow to rain is exactly what we expect if winters become warmer, because that precipitation, if there's a pretty hard threshold for whether or not the water falling out of the sky is falling as snow or is falling as rain, and it's very temperature dependent. So, we do expect for physical reasons that we're more likely to continue to see cold, snowy winters than cool summers, and we can talk about why that is. But we've certainly, in our research, have asked a similar question to what you've described: is how, as global warming persists, for how long can we expect to continue to see cold winters? And certainly we do expect that they'll become less frequent, and that more of the precipitation will come as rain than as snow.
Thank you.
We have a viewer question, Noah. This viewer asked, do the volcanoes under the Arctic, do they have anything to do with the heating that's going on there? This viewer wants to know.
Yes, there has been some work on geothermal heating and how this affects ocean temperatures and even the ocean circulation. We do know that the increase, that heat content in the ocean, so basically how much energy is in the ocean and how that's reflected in the temperature of the ocean, that has increased historically, and that when scientists try to understand the causes of that increase in the heat in the ocean, that is primarily explained by human emissions of greenhouse gases such as carbon dioxide. So there's been a lot of work on that very question of warming of the oceans and how much is due to greenhouse gas emissions and how much is due to other causes, and that attribution is very clearly both for how much warming there's been, and the spatial pattern of that warming really points to human emissions of greenhouse gases.
Okay, great questions, guys. And before I get to some more of our viewer questions, I want to answer some more. Have Noah answer some more of yours. So, who else has one for Noah?
I have a question, Sarah. In Italy, we've experimented a very warm winter. I live in the northeast part of Italy, and the problem here that we had no snow whatsoever for the winter. Instead, the snow affected the southern part of Italy as high as they got 9 feet of snow this year, and the snow reached as south as Algeria and Tunisia. Do you think the barycenter of the cold is moving to the south?
Well, this relates to the earlier question about Northern Europe and rain versus snow and cold winters and warm winters, and you'll often hear people say, well, weather isn't climate, and I disagree with that, actually. I think the weather that we experience is an expression of the climate system, and as global warming occurs, that will very, very directly impact the weather that we experience. So this is certainly a question that's we want to understand. The challenge is that the climate varies from year to year, and so what we're doing now in our research is asking questions like, if we have a year like you're describing in Italy and North Africa, we can ask, what are the odds that a year like that would occur with no global warming, and what are the odds that it would occur with global warming? And so that's really, what you're describing is really right on the cutting edge of climate research right now, in trying to attribute individual events, whether they're large tornado events or large snowstorms or heat waves, or more seasonal or annual events like you're describing. So I think that it's too early to say whether or not we expect that the snow to move from the northern Mediterranean into the southern Mediterranean, but it's certainly the kind of question that we're pursuing.
So Noah, go ahead, Pio.
I just have a short follow-up on the question. I've seen species of animals that I've seen when I was living in Florida, now nesting here in northern Italy. Is that a phenomenon, or is just is it something that is not so important? Like egrets and blue heron, they are nesting here.
This is a question that has been addressed in the literature and does have a pretty clear conclusions drawn from scientific evidence, and that is studying the patterns of changes in the distribution of plants and animals, as well as the timing of their kind of biological events, whether it's when flowers come out or when birds migrate, when the first sighting of a bird in a location occurs. And there have been a number of analyses looking across the globe at evidence for the kinds of range shifts that you're talking about. And these have been systematically and scientifically attributed to global warming, and in some cases, global warming caused by anthropogenic greenhouse gas emissions. So I'd say for the question of the species ranges and timing, that's much more robustly understood. And in fact, there was a paper just in the last few weeks suggesting that the earlier experimental evidence for the timing of plant stages, like first flowering, was actually underestimated, and what we've observed in reality historically has been accelerated. The response to global warming has been faster for those plants than was originally predicted.
So let's talk a little bit about some of those studies. And this is a study here from the National Oceanic Atmospheric Administration that talks about carbon dioxide levels reaching milestones mark at the Arctic sites. Is there any way to harness, Noah, the consequences of global warming in order to create a benefit? And is any work out there looking at harnessing the consequences for a benefit?
Yeah, so a lot of the work in what's called climate change impacts, so what will happen to natural and human systems as climate changes, what is already happening to natural and human systems as climate changes. A lot of that impacts work is focused on trying to understand what the benefits might be. So an agnostic look at what the response might be. And we've done some work on a number of these systems, but where the benefits come to mind in particular is our work on premium wine and the cultivation of premium wine grapes, which is very sensitive to temperature. And we've looked across the United States and in more detail in the western United States, which is really where most of the value of the U.S. wine industry is located. And we find that what are currently the highest value growing areas are potentially facing a decrease in suitability from temperatures that are too hot, but that other areas of the western United States potentially have opportunities as they become warmer to move into a more optimal growing habitat, a temperature regime. So that's an example where we've been very agnostic about costs and benefits, and we're perfectly willing to write about the potential benefits where we find them. And for us, it's really about trying to understand how the world works and being objective about that.
In our area, obviously, we are very interested in corn production. Where do you see corn production moving? And I believe you had sort of said earlier, in the coming decades, we might see that move to the Great Lakes and up into Kempton's region up in Canada.
Yeah, so we published a paper in April trying to understand how climate and both the average climate that we experience and also climate extremes, extreme weather events such as heat waves, affect the year-to-year volatility of corn yields in the U.S. and how that affects corn prices in the U.S. And we started by asking if all of the corn growing regions stay as they are in the United States, what's the impact of climate change? And then we asked, given the climate change that we expect over the next 3 decades, where would these areas need to move to find the same climate that occurs in the Corn Belt now? And particularly for extreme temperature, we found that those growing regions will really, that equivalent climate will be found in the Great Lakes region and into Canada. And that's over the next 3 decades in our our climate model experiments.
Speaking of Canada, Kempton Lamb in Calgary, what are you seeing in your area as far as climate?
Well, climate-wise, the weather seems to be more extreme. It's either we had a 100-year flash flood and whatnot happened a few times in the last few years. Like the underpass are designed to absorb certain rainwater, and then it keep on flooding those newly built underpass. But I've actually got a research-related question to ask Noah. So Noah, I mean, in Canada, our Polar Environment Atmospheric Research Laboratory was earlier this year shut down its year-round operation. So basically, I think only part of the year is open. And in addition, because of cut funding also, there's apparently a world-renowned area, experimental lakes area. It is going to be shut down, and a series of 58 freshwater lakes, and I understand that's quite important to research. My worry is those data being taken away, how is it going to impact research scientists like yourself?
Well, I'm conflicted because my research program receives a lot of generous funding from the American taxpayers through the federal government. So I want to make sure that's on the table. I think in spite of that, I'm with that caveat. I certainly will say there's a lot of value in supporting research, both climate research and in other areas. Like I say, we're working hard to understand how the world works, and we need the research support in order to maintain that progression of knowledge. And for climate change, when people are asking these questions about is this year different because of climate change, we really need long continuous records to answer those questions.
Yeah, to me, when those data are gone, then it's gone. Like we lost an important bunch of data points for all scientists to
yeah, and this is
study.
true for the in situ, so in the on the ground measurements like you're talking about, and also for satellite remote sensing. There's with funding cuts now, there are questions with the U.S. space program, of how continuous those satellite observations will be, and you're right that once there's a hole in the record, there's a hole in the record, and it becomes much more difficult to answer the questions that we get from the public, that we get from elected officials about, are these changes that we're seeing due to global warming or not? Like you say, we really need those long-term continuous records.
Let's go to Robert Redl in Austria. What are you seeing in your area in Vienna?
Yes, I believe, sorry, that the country Austria is a little bit too small to look at the climate. My question would go into a direction when we look at the cause and the symptoms. So most of the time, I do not know how old the whole topic is, but since, let's say, 1 or 2 decades, we are discussing about the symptoms and trying to find causes. But what is done as measurement against it? What would you see as the most important steps to do against it? And for example, when we move our production to foreign countries, to Asia and other regions, shouldn't all the tax money that we get from the CO2 emission taxes in Western countries and take them to make action in those countries where we have now moved all the nasty CO2 production and stuff like this?
Yes, this is a great question about what to do if an individual or a country decides that they want to cut their greenhouse gas emissions. And I think one important point is that the reason that we're in the situation we're in with increasing greenhouse gas concentrations, clear global warming, clear link between that cause from the greenhouse gas emissions and the global warming, we're in this situation because of the benefits of energy consumption. And we all experience tremendous benefits. I experience tremendous benefits from energy consumption. There are a large fraction of the population that doesn't have reliable access to energy resources. And so this is where this fundamental challenge comes from, that global warming is really a side effect of the benefit that we get from energy consumption. And so if we ask what can we do about it, there are a whole host of possibilities, and they all have trade-offs. But in general, the two main categories of policies are either direct tax that prices the emissions of greenhouse gases by trying to internalize those externalities directly, and then the other method is the cap and trade, which is essentially having an imposed cap on the total emissions, and then the market decides what the price of that right to emit is. So there are fundamental economic and environmental differences between a tax versus a cap and trade.
I want to bring in Mike Downs from the UK. Mike, tell people specifically where in the UK you are.
I'm right in the centre in Warwickshire there. Hi, my question is it's just from a report actually published today. I'm an ex-teacher this is from Cardiff and Nottingham University about this psychological angle behind climate change, which is titled "The Message Needs to Be Closer to Home" to hit, say, researchers. So in other words, people won't do anything unless they feel the problem is closer to them, which is something I struggle with because such a world is.
Yeah, so I saw your post this morning about that, and actually I was glad to see that because I'm involved in a project that's asking a very similar question in the Midwest of the United States, and I wasn't aware of that work until you had pointed it out. So I thank you for posting that, and I need to go read the original paper now. But I think the fundamental question is how do humans respond to information about their environment, about environmental change, about how what we do affects the environment, and it's specific for this study, how our energy consumption and emissions of greenhouse gases affect the climate that we experience. And there are a lot of hypotheses, and one of the leading ones is that more local information about local scale changes will make individuals more sensitive to the quote threat or the prospect of climate change. I'm not sure that that's correct. It's a hypothesis, and that's why we're trying to test it systematically, and I'm interested in this paper. But it may be from a behavioral change point of view, that may be the case. I'm a scientist, so I'm about creating hypotheses and testing them, and it may be that this local angle is not correct, or there may be a cultural overlay that in some regions people are sensitive to that local information, and in some regions they're not. And in reality, not all parts of the world are going to experience the same climate change or the same severity of climate change. So there's probably a lot of heterogeneity in that information response, that psychological angle, as you say.
How about you, Michael Tucker, in Brisbane, Australia?
There's been a lot of talk about the ozone layer opening up, and studies were done from the Australian CSIRO, I'll be 30 years ago at least now, probably even 40, and so that was probably the first precursor to the studies that you're involved with now. But isn't this whole thing just part of normal evolution? That this has happened many times before, and so we experience change anyway. But what are your findings around that sort of stuff? Because perhaps it's just a normal thing. If we look at here and now, we're doing fine, and many other people are, but there are many disparities within that whole situation.
Yeah, so a lot of my work actually is focused on paleoclimate, on periods of Earth history before either before humans had evolved or before the Industrial Revolution, and trying to understand what caused climate to vary and change without human influence. And we have fantastic geological records that very clearly show that Earth's climate changed dramatically without any human activities at all. And this goes all the way from what people call snowball Earth, where there's geologic evidence that most of the globe was covered in ice for long periods of time, to all the way to what people call super greenhouses, where like when the dinosaurs were the dominant life forms, and there were rainforests in the middle of North America. So very, very different climates with no human influence at all. And I guess the important thing to keep in mind is that just because Earth's climate changed before humans were influencing Earth's climate doesn't mean that humans aren't influencing Earth's climate now. And in fact, we know from the geologic evidence of what happened in other periods of Earth history when greenhouse gas concentrations became high, how the climate system responded, and that's where a lot of our understanding of what we expect over the next century comes from.
All right, lots of great questions. Guys, we've gone about 30 minutes. I do not want to hold all of you hostage, but do any of you all have any additional questions for Noah before we close out here? Obviously, we need much more time to discuss this.
No.
Not really.
No.
No, thank you so much
Thanks a
for
lot.
having
Thanks a
time
lot.
for us.
Sounds good. Noah, any parting words before we go? We appreciate your time and sharing your expertise with us.
Oh, I'm really grateful that you've had me on, and grateful for everyone joining and having great questions. It's I'm very stimulated by the questions, and yeah, I mean, I think we're working hard to try to understand how the world works and how humans interact with it, and you know, these are all really important questions that really are at the cutting edge of scientific research. So I'm glad that you all are thinking about it, and thanks for talking about it.
Thank you.
Absolutely. Thank you for your time. And again, if you'd like any more information about any of the articles that you mentioned, you can see them posted on Google Plus on Noah Diffenbaugh's page as well. So thanks so much for joining us.
Thanks a lot.
Yeah, guys,
See you. Bye-bye. Thanks a lot.
Thank
later.
you.
Thanks for your time.
Bye.
Bye-bye.
Bye.
Ciao, ciao, everybody.
Ciao,
Ciao,
ciao.
ciao, ciao.
Ciao, ciao.
See you guys. Bye-bye.
See you guys.